The impossible mirror. If antimatter touches matter, both instantly disappear, converting completely into energy. And because of this fact, antimatter has always been treated as something dangerous or destructive. But that framing misses the deeper problem. The question should never have been why antimatter is dangerous. The real question is why the universe ever allowed antimatter to exist at all. Antimatter does not help stars form. It does not build planets. And it does not create life. Whenever antimatter meets matter, both are erased completely, leaving only radiation behind. And yet the universe produces antimatter constantly. It appears in cosmic rays, in lightning storms, in particle accelerators, and even inside medical machines. Antimatter is not rare, and it is not hypothetical. According to Richard Feynman, the most honest physicist of the 20th century, the real shock is not that antimatter exists, but that the universe could not exist without it, not philosophically or symbolically, but mathematically. By the late 1920s, physics believed it was nearly complete. Newton explained motion, Maxwell unified electricity and magnetism, Einstein explained space and time, and quantum mechanics described atoms. But one problem refused to disappear: the electron. Electrons behaved like particles and like waves at the same time. Early quantum equations worked only at low speeds. Once relativity was added, the equations broke. Paul Dirac searched for an equation that respected both quantum mechanics and the speed of light. In 1928, he found it. The equation was elegant and precise, but it carried a terrifying implication. It allowed electrons to exist in negative energy states. If such states were real, electrons could fall endlessly, releasing infinite energy and destroying the universe. Most physicists assumed the equation must be wrong. Dirac trusted mathematics instead. Rather than discarding the solutions, Dirac proposed that all negative energy states were already filled, forming an invisible background later called the Dirac sea. Because of the exclusion principle, ordinary electrons could not fall into these states. If one of the hidden electrons were knocked out, the absence would behave like a particle with the same mass as the electron but opposite charge. At first, Dirac thought this hole might be the proton, but experiments proved otherwise. A new particle was discovered identical to the electron in every way except charge. The positron existed. Antimatter was real, and physics crossed a point of no return. Richard Feynman later rejected the idea that antimatter was a strange cosmic ad. On to him, antimatter was inevitable. Once time was treated correctly, the equations describing an electron moving forward in time were mathematically identical to those describing a positron. Moving backward in time, antimatter was not a different thing, but a different direction through space-time. What we call annihilation was not destruction, but reversal. Nature does not label matter or antimatter. It only allows paths through space-time. Once quantum mechanics and relativity are combined, antimatter must exist. Without it, energy conservation and causality collapse. The real mystery is not why antimatter exists, but why anything survived once it did. The universe that should have vanished according to the laws of physics, the Big Bang, should have been perfectly fair. For every particle of matter, an antiparticle should have been created alongside it. When matter meets antimatter, they annihilate completely, leaving only radiation. If symmetry were perfect, the universe should have erased itself almost instantly, leaving no atoms, no stars, and no observer, and yet something survived. Observations show that for roughly every billion antimatter particles, there was one extra particle of matter. That single excess built every galaxy and every human. There was no dramatic imbalance, only a tiny statistical tilt, barely large enough to save existence. Physics is built on symmetry, and symmetry creates conservation laws. When physicists discovered that certain particles violated symmetry, they were unsettled. In 1964, experiments showed that kaons behaved differently than their antimatter equivalents, violating CP symmetry. The laws of physics were not identical under charge reversal and mirror reflection. Nature slightly preferred matter. Richard Feynman was disturbed by this, not because it was complex, but because it felt arbitrary. The asymmetry did not feel inevitable. It looked patched into the rules. Feynman tied the problem back to time. If antimatter can be interpreted as matter moving backward in time, then CP violation means time itself is biased. The universe is not perfectly reversible. That bias decides whether anything exists. Too much symmetry, and everything annihilates. Reality exists only in a narrow window. The universe was not designed. It was barely allowed. Antimatter is not dangerous. It follows the rules honestly. Matter survives only because the rules bend slightly in its favor. No one fully understands why that bend exists. The universe that owes us no explanation. If antimatter once existed in equal amounts, then it should still be visible today. But observations show no antimatter galaxies, no antimatter stars, and no cosmic ray and gamma. Ray scans suggest antimatter is almost entirely gone. Every proposed explanation introduces new particles or new forces without strong evidence. Richard Feynman would have disliked these ideas, not because they are wrong, but because they add complexity without clarity. Feynman's position was brutally honest. We do not know why matter won. Pretending otherwise is dishonest. The universe is under no obligation to be balanced, meaningful, or comforting. Equations either allow something or they do not. Modern quantum field theory treats matter and antimatter as orientations in space-time, reframing the mystery as why time itself favors matter. One extra particle per billion, a microscopic imbalance that decides everything. Existence is not guaranteed. It is barely legal. Antimatter is not the opposite of matter. It is proof that the universe almost canceled itself. Symmetry nearly won. If Feynman were asked why antimatter exists, he would say because the equations that allow electrons also allow positrons. The universe obeys equations, not stories. And if asked why antimatter did not win, he would say physics does not care whether the ending satisfies us. Reality is symmetric enough to be elegant and broken enough to exist.